reacting. So it's not, this part is not too complicated, but you just have to be paying attention and doing your math, simple math correctly. All right, so we looked at some examples. So now we're going to give some definitions. What is oxidation? What happens when something is oxidized? Yep. So when you oxidize something, electrons are lost. What happens when you reduce something?
Gains electrons.
Yep, you gain electrons. Most people are good with those definitions. Here are some that give people a little bit more trouble. Oxidizing agent. So it is an agent of oxidation. So it accepts an oxidizing agent is something that wants to oxidize something else, so it gets reduced itself. So it's an agent of oxidation. It runs around trying to oxidize other things, but it itself is going to get reduced. And then you could probably figure out what a reducing agent is. It's an agent of reduction. And so it itself will be oxidized. It'll try to reduce something else. It'll run around trying to reduce something, trying to give off its electrons, donate its electrons so that it can be oxidized. So keep these definitions in mind because you're going to be using them a lot in this unit. So now we're going to use them. We're going to look at a reaction, and we're going to think about what's being oxidized and what is being reduced. And this particular type of reaction, a disproportionation reaction, the same element can be both oxidized and reduced. So let's break this down into two equations. In every reaction, there's going to be an oxidation and a reduction, and so you can write those separately. And poor sodium. Sodium is getting kind of a jip a lot in these last few units in acid-base, and here again, it's a spectator ion here, so it doesn't even make it into the equation. And it was ineffective as a conjugate acid. It hasn't really been doing very much recently, but that's okay. All right, so let's look at what's going on here and try to figure out what's happening in terms of what's being reduced and what's being oxidized. So let's start over here. Let's think about what the oxidation numbers are in this particular molecule. So what would be true about oxygen here and chloride? Is this, what do we know about this combination of things in terms of oxidation numbers? So let's start with chloride. What's that going to be here? So, oh, I'm sorry on that side. Let's start on that side. So we have a -2 here, and the whole thing is going to be -1. And so what is that about chloride? +1. Right. So this is one of the exceptions. Chloride is usually -1, except when it's with oxygen. And here we have an overall charge of the molecule of -1, so it all has to add up to -1, and it does. All right, so now let's do that side. So what's going on here? Are they going to be similar or different? Let's start with the oxygen. What's that going to be? So we have 3 -2s. It's not a peroxide, so it's -2 for oxygen. The overall has to be equal to -1. So what is chloride here? +5, right. So that's unusual, but that's what it is. So we use our rules. Chloride is usually -1, except when it's with oxygen, and then it can be something different. So here chloride's going from +1 to +5. So what's happening to it? Is it being oxidized or reduced?
Oxidized.
Yep. So it's going from +1 to +5. So we have an oxidation going on. So to tell whether something is an oxidation or not, you need to figure out what the oxidation numbers are and then see what's changing in the course of that reaction. All right, so down here, we've already done this one. So we can put that down here. So we have -2 for oxygen, overall -1. And so chloride is +1 again. And what's the oxidation number on the other side for chlorine? -1. I just have to look. And so that's -1. So here we're going from +1 to -1. So what is that? That's a reduction. And if we had figured out that they're both oxidations, then something we would have done incorrectly, because in this reactions you're going to have oxidations and reductions.